Hello everyone, my name is Akanksha Solanpurkar and today I will be presenting a topic named as Image Classification using CNN, which stands for Convolutional Neural Network. So in this presentation we will understand why image classification is important, what actually CNN is and how it works, what challenges it faces, and finally a short summary of its importance in our world. So let's begin. Before we dive into the technical details, let's first ask why image classification matters. So every day we capture billions of images using phones, cameras, satellites, sensors. So to make sense of these images, computer must be able to understand what they show. So that's where image classification comes in. It helps computers automatically identify and categorize objects in an image. So this is used in many areas of our lives. For example, in healthcare, doctors use AI system to analyze X-ray and detect diseases. Even in security, cameras use facial recognition to identify people. And in self-driving cars, image classification helps the vehicles recognize roads, pedestrians, and traffic signs. So, in simple words, image classification teaches computer to see and understand picture, just like a human do. So, for example, suppose we show the model two pictures, one of a cat and one of a dog. Then the model analyzes their shapes, colors, and features, and then correctly labels them. So that's why image classification is one of the fundamental building blocks of artificial intelligence and computer vision. Now that we know the importance, let's move on to the what CNN actually is. So CNN stands for Convolutional Neural Network. It's a type of deep learning model specially designed for analyzing visual data such as images and videos. The key strength of CNN is that it can automatically learn important features from raw image pixels. So we don't have to manually program what to look for. Let's briefly understand the main layers of CNN. So the first one is convolutional layer. It detects small patterns in the image like edges, corners, and textures. Second one is a pooling layer. It reduces the image size but keep the essential features, making computation faster. And the third one is a fully connected layer. It combines all the learned features and predicts the final class. Together, these layers perform simple pixel data into meaningful information. So let's see the example. So in a famous MNIST dataset, CNNs are trained to recognize handwritten digits from 0 to 9. At first, the model detects small details like curves and lines, and then it combines them to recognize a full digit. So basically, CNN mimics how brain visual system works, like identifying patterns step by step. Now let's see how CNN works step by step. So when an image enters the CNN model, the first step is the input layer. The image is converted into grid of pixels, each pixel holding the intensity value. The second step involves convolutional operations, filters which can also called as kernels, slide over the image. Each filter extracts specific features like horizontal edges, vertical lines and curves. After convolutions, a ReLU function is added non-linearity so the model can learn from complex patterns. The third step involves pooling layers. Here the image is downsampled, which reduces the data size and prevent overfitting. And in filtering, the 2D feature maps are converted into a single 1D vector so that they can be fed into the next layer. So next step is involve fully connected layer. Here, the network learns relationship between features and classifies of the image. And the second last step is a output layer. So finally, the CNN outputs probabilities for the each class and select the one which is highest score. So this is how CNN gradually turns raw pixels into a intelligent prediction. So let's see the example. So when we use the C410 dataset, CNN learns to classify objects like cars, birds, ships, and airplanes. So at first, it sees only patterns and colors. After training, it can correctly label complex real-world objects. And finally, this layered approach makes CNN powerful, efficient, and adaptable to various image-based tasks. Even though CNNs are extremely powerful, they are not perfect. So let's look at the some of their key limitations. First one is large data requirement. CNN needs thousands or even millions of labeled images to learn efficiently. Without even enough data, the model's accuracy drops. The second one is high computational cost. Training deep CNNs requires powerful GPUs and long training time, which can be expensive. And the third one is sensitivity to image quality. If an image is blurred, dark, or taken from a different angle, then the CNN may misclassify it. And the fourth one is interpretability problem. CNN often work as a black box, like they give a result, but it's hard to know exactly why a decision was made. So, for example, suppose a CNN was trained mostly on bright daylight image, when when given nighttime photo, it may fail to recognize the same object because lighting conditions change. So, while CNNs are excellent learners, they still need clean data, proper tuning, and continuous improvements of real-world accuracy. Now let's summarize what we have learned so far. Uh, Image classification using CNN is one of the important point in artificial intelligence. It allows computers to automatically identify and categorize objects with remarkable accuracy. As we discussed that CNNs have a layer structure, each layer has a specific job, like convolutional layer for pixel detection, pooling layers for data reduction, fully connected layers for decision making. So this network have revolutionized industries. In healthcare, CNN detects decisions from X-rays and MRI scan. In security, they power facial recognition systems. In transportation, they help self-driving vehicles identify surroundings. In agriculture, they detect plant diseases and monitor crop qualities. So, with high quality data and sufficient training, CNN achieves human level accuracy in many tasks. So, however, we should remember that the performance of CNNs depends heavily on a data diversity and hardware power. So, for example, in healthcare, CNN can scan chest X-rays to identify early signs of disease or other conditions, so helping doctors make faster and more accurate diagnoses. So, CNNs not only improve efficiency but also contribute to life-saving innovation. Thank you.